Hello viewers, my name is Dr. Vijayakumar, Assistant Professor of Statistics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Today my topic, analysis of variance. The subject is statistical methods. The subject code is ASCA202A. Analysis of variance, ANOVA. What is analysis of variance? Is a statistical formula used to compare variance across the means or average of different groups. A range of scenario used it to determine if there is any difference between this mean of different groups. The analysis of variance is a collection of the statistical model and their associated estimation procedures, such as the variation among and between groups, used to analyze the difference among means. ANOVA was developed by the statistician Ronald Fishers. ANOVA is based on the law of total variance. That is where the observed variance is a particular variable is partitioned to into components attributes to different source of these variations. In it is simplest formula, ANOVA provide a statistical test of the whether two or more population means are equal, and therefore generalize the t test and f test, otherwise beyond to means. In other words, the ANOVA is used to test the difference between the two or more means. So there are two types of classification is there. This is for first one is one-way classification, second one is two-way classification. So we have to handling for this one-way classification. So general procedure is there. This is for null hypothesis H0. We had to define as the H0. There is no significance difference between these treatments. So one-way classification only for treatments wise we had to handling here. The alternative hypothesis H1 is there is a significance difference between these treatments. So correction factors CF is G square divided by N, where G is a grand total, N is total observations. So total sum of square TSS, that is equal summation I square minus C correction factor CF. The treatment sum of square TSS, that is equal to summation C I square divided by M minus CF, where Ci ith treatments. So errors sum of square ESS, that is equal TSS minus T or SS, total sum of square minus treatment sum of square. So on our tables we had to handlings in these calculated values. Source of variation, treatments, errors, total. Sum of square, TRSS, ESS, TSS. So treatment sum of square, error sum of square, and the total sum of square. So next column is degrees of freedom, t minus 1, n minus t, n minus 1. This is for treatment sum of square, n minus 1 degree, error sum of square, n minus t. Another one is treatment sum of square, n minus 1. So mean sum of square, mean treatment sum of square, that is equal treatment sum of square divided by t minus 1. Mean error sum of square, that is equal n minus t. This is for calculating error mean sum of square divided by error sum of square divided by n minus t. This is for the error sum of square. Errors we had to handling the mean sum of errors square. So f calculated values, f c mean treatment sum of square divided by mean sum of square error. So you have to handling this type of calculated value is there. This is for general procedures. Another one is table value is there. So generally you have to handling for the 5% level of significance. Last one is the inference is there. This is for calculated values, and less than table values we had to handling this. This is for general. H0 is true. This is for we had to handling for this general procedures. This is for one more this is for the problem 1. The following tables is the yield of the 15 sample of the floats under the 3 varieties. The 15 sample of float under 3 varieties. So 3 varieties is A, B, C. That is called as 3 varieties. So 15 sample of flats is there, the 20 up to 32. To test using analysis of variance whether there is any significant difference in this average yield of the seed. This is for the problems in one-way classifications. The solution is null hypothesis. H0, there is no significant difference between the 3 varieties of seed. That is called mu1, that is equal mu2, that is equal mu3. We had to denote it as mu1 that is equal mu2 that is equal mu3. This is for null hypothesis. Alternative hypothesis H1, there is a significant difference between the 3 variety of seeds. That is called mu1 not equal mu2 not equal mu3. This is for alternative hypothesis. This is calculation of these 3 variety of seeds, 3 variety of seeds in plants. So total is there. So row wise we have to add these totals. This is for 20 plus 18 plus 25. We have to sum of these values 663. So although we had to calculate these total values, so total value you have to add this total of these values, that is called a grand total 330. First we had to handling for the correction factors. CF, that is equal to G square divided by N. So 330 is a grand total whole square divided by 15 is a total number of samples, that is called a seed. This is you have to calculate this 7260. This is for correction factors values CF. The total sum of square TSS summation xi square minus correction factor. All the seeds we have to square up the individual of the square minus correction factors values TSS 330. The treatment sum of square T or SS, the summation A square plus summation B square plus summation C square. Those are divided by minus correction factors. You have to handling for this three variety of seeds is there. So this is for the total of the summation A square plus summation B square summation C square values divided by 3 minus 7260 is correction factors. So calculate the 190. So error sum of square errors ESS total sum of square minus treatment sum of square, that is equal 140. The source this is for ANOVA tables. We have to handling for treatment wise errors and totals. The sum of square treatment sum of square value is 190, error sum of square value is 140, total sum of square is 330. So degrees of freedom n minus 1, sorry, t minus 1, t is a treatment wise. So 3 variety of treatment is there. This is 3 minus 1, 2. The error sum of square 15, n minus t. N is a number of observation, t is a total 3 variety of t. So we have to minus this value 12. So n minus 1 is a total number of values. So mean sum of square value 19 divided by 2, that is equal 95. For error sum of square divided by 2, that is 140 divided by 2, that is equal 11.66. So you have to calculate 95 divided by 11.66. You have to calculate the F calculated value is 8.14. This is for ANOVA table calculated F calculated values. The table value is F2, 1, 2, that is 3.88. So inference value is F calculated value greater than F table values. We had to handling for this table values is 5% level of significance. So 5% level of significance value is 0.05. This is for 3.81. The inference value is FC, F calculated value greater than F table values. That is for 8 point something greater than calculator value 3.81. That is reject our null hypothesis H0. So 3 variety of seed is rejected. That is 15 plot of samples. This is for very important in this inference. So H0 is reject our null hypothesis. Otherwise, we had to some difference is there in this variety of seeds. Thank you very much.